Platform as a service is evolving in Azure, and you may have seen something pop on called Azure Functions.
Let's mash on that.
Hi everybody, and welcome to another episode of the ASPNET Monsters. In today's episode, we're very fortunate to be recording in the Channel 9 studios and also to have a guest with us direct from Microsoft. It's Chris Anderson. He's going to tell us all about functions.
Yeah, why don't you start a little bit with your role and the work that you're doing with your team?
Sure, yeah. I'm Chris Anderson. I'm a program manager working for Azure. I mainly focus on web jobs and Azure Functions.
Right on. Okay, so Azure Functions, there's a previous incarnation, right? So this is kind of the grown-up thing. Previously we had web jobs, and there's some differences there. Can you highlight how that kind of evolved and how that's shaping up?
Right. Yeah. So web job, saying Azure Functions is like the grown-up version of web jobs is maybe a little bit derogatory towards web jobs. Web jobs itself is a really cool SDK, right? But there was a notion there that the patterns that the SDK was enabling inside of web jobs were so cool, so powerful, that if only we could make it easier to just walk up and start using, it could blow up. And so what we did was we built a managed service, a managed platform around that web jobs concept. So this ability to just write a function and have it react to events that are happening inside of Azure and potentially even outside of Azure. And then also have the really cool powers that came with the input and output bindings that web jobs offered us. We can really kind of do that full spectrum of things that web jobs allowed us to do. Web jobs is still technically more powerful because you can do a lot of things that we, in our opinion, didn't let you do in functions because it didn't fit into our pattern.
And that's kind of an important thing to point out too, because there's people who are investing now in web jobs. They're taking the heavy lifting of their website and they're baking that into the app service stuff. Is that going away?
Absolutely not. Some of our biggest, most successful customers on app service, a lot of them end up using web jobs. It was one of the reasons that we felt very confident about investing on top of web jobs as a technology, is that we knew it was important to our platform. And so really just merging more of that technology into our platform was all goodness. And you'll see that everything we do to functions goes through all of the web jobs repos, all the code bases there. So all the investments we make for functions on performance, etc., go straight through web jobs.
Yeah, and it's one of those things too, like when you start getting in and working with web jobs SDK, especially from C#, like in Visual Studio, and I think we're going to get a chance to do that today. That is just even seeing, similar to the MVC stuff with model binding, like the input and output binding and whatever, and being able to bind directly to those things that are part of the platform as a service suite. It's super powerful, right?
Yeah. So when you say input and output binding, you mean that we can drive a web job off of like a queue or a storage container, something like that, right?
Yeah, so we've got a variety of triggers, HTTP timer, storage queues, service bus topics, storage blobs, an event hub, and probably 2 or 3 other ones that I'm missing.
And so is that more than they used to be for web jobs?
We actually
scheduler didn't exist?
Timer trigger actually we added about a year ago around this time actually with the release of our extensions model. So now you can actually write these custom extensions, and one of the extensions we wrote to kind of prove that out was in fact the timer trigger in the first place. We also added error triggers and things along those lines to help you kind of automate reactions to things happening inside of your web jobs. And then for functions themselves, we actually added event hubs because serverless computing and event streams really are just a match made in heaven.
Absolutely. Okay, so normally when we're talking on the ASP.NET Monsters, we're talking about ASP.NET Core, and I know that with a little bit of noodling around, you can get web jobs running with an ASP.NET Core project.
Yes.
So what's the story for ASP.NET Core inside of Azure Functions?
So you can run today just your standard ASP.NET Core console application as a just regular old web job. The Web Jobs SDK itself still hasn't had all its dependencies updated to support .NET Core, and then of course that means that functions built on top of that don't yet support that.
So if you're doing a Web Jobs SDK use right now in a core console application, you're going to be targeting 4.6.1 or something like that, right?
That's exactly what you're going to end up with, yeah. And so what you will see is we are built in a lot of the same technology pieces that .NET Core uses. In order to do the C# scripting and the way that we did it, we ended up building a lot of those parts. It's really important for us to get cross-plat tooling and potentially even cross-plat hosting later on in the future. And so you'll see us move really fast in the direction of supporting .NET Core because that is the main enabler of us to support those kinds of scenarios. So I can't give a date, but the thing is we're open source, right? And so you'll see us go ahead and start creating some issues, creating some milestones for these things, and you'll be able to see the pull requests that actually go implement this on our platform. So I can't say when because it'll be when the developers decide it's ready, but you'll see us as we're building it.
You heard it here first by Christmas 2016.
Oh, Fabio's going to kill me if you hear that.
Okay, well, let's dive in and have a look at some of how this works. And I think the first place we can go is have a look in the portal.
Sure, yeah. So one of our first goals with functions as we were trying to move to make web jobs easier to adopt was, of course, to make it faster to actually get in there and start using it. And where that really comes into use is I can just do it in the portal, right? If I'm just writing a little bit of code, there's no reason that I can't write it inside of a web portal editor, especially if it's just a very simple one.
Mocking things out, getting some groundwork laid just to see if this works.
GitHub webhooks, or even. Like if I want to do webhooks on different things, there's not going to be a lot of complex logic inside of there. Maybe I just want to go ahead and process something and send something quickly back.
Right.
Those things don't really require necessarily doing something entirely locally and very complex. And so we wanted to enable people to just move quicker when it is a quick and simple thing. And of course, I'll show you how we're also going to support you when you want to move more kind of paced and safe, if you will.
Yeah, yeah.
So in this case, I just have a very simple demo of I have this HTTP triggered function that's just sitting at one of our normal routes. So we would do HTTP, we would do your function app name.azurewebsites.net, whack API, whack your function name. But you can also choose custom routes. So you can control what that route looks like. And we're in fact using ASP.NET's custom routes functionality. So when you specify a custom route, you can actually use all the exact same rules you would with ASP.NET. So that makes things easy to learn if you're already familiar with those paradigms.
And take those skills and move them over from ASP.NET Core over and MVC over over into the space. Okay.
So can I change the top level domain too?
You can change, you can do custom domains.
Okay.
And the one thing is to remove the API piece in the middle there, there's just one little under the cover setting you can remove. But you can completely control what the entire surface area of what that function's API surface area looks like.
Right on.
Right, cool.
So in this case, I'm just using a relatively basic one, so just one that has the default name. And the cool thing here is I can go ahead and I can take this and I can ping it. But in this case, I'm expecting a post, and so I'm just going to go ahead and do that via Postman. So here I have this very simple example where I've got a name for an item, and there's going to be a count on there. And I'm going to, what I wanted to do was take the item and send it to a queue to be processed, essentially.
Right.
And so here I'm going to go ahead and send that along.
So this is a simple scenario, but this is really good for helping your website be able to scale out, because if you've got something that happens in the background and you don't want to do the heavy lifting on your site, maybe you're triggering an email template rendering or something like that, you can push that off to the queue and then carry on. And meanwhile, we haven't had to do much work at all.
Exactly. You definitely want to accept and then pass on the work, not do that synchronously as part of a request, because that gives you a lot more robustness and scalability in your system. Okay. And functions, a lot of that stuff comes out of the box because we encourage those patterns.
So would a pattern be here, like something like a document generation, I might have a function that's entire role, which is to take the message and put it on a queue, and then an additional function would take that off and do whatever.
And return you the status of that item, and then potentially return you the actual item itself if it was completed.
So that kind of lends to the idea of chaining these triggers together and having the functions pass chunks and fan out as required. And
that's where the WebJobs programming model comes really heavily into play here, because you can see on this code that I have on my screen, I'm highlighting output. And the great thing about this is actually hooked up to my queue that I want to send this out to via this integrate tab. So here on the integrate tab, I've said this parameter called output. I'm going to go ahead and send that to a storage queue of name item queue inside of this storage account. And you can see here we have a nice GUI to actually hook those connections up. You're not having to juggle connection strings everywhere just as you're trying to initially develop things. But you can control everything underneath the covers here. So it's all just kind of this really, really nice dressing, but all the power underneath is mostly still available for you if you want to dive down. So in fact, it's as easy as just clicking on this advanced editor section here, and you can see your full configuration that we're using under the covers.
Right on. So not hiding anything, there's no hand waving here. This is everything that is happening is exposed through the UI.
Exactly. You have as much control as you can possibly give you without touching a lot of the way that we end doing the compute management itself. That's where the cutoff ends up being, is the infrastructure management itself, which is good. You don't want to do infrastructure management when you're using a PaaS. Right. So now that I have that hooked up to my queue, what you'll notice here is that this thing, if I call this again with my logs up, and you can see the streaming logs as you're developing here inside the portal, you can see that we started, we completed, and if we go to this other function that I've got, this one's actually hooked up to listen on that exact same queue. So you can see here it's item queue, and it's the exact same storage account connection string. And so if we go look at the logs for this one now, you'll see that this one actually just ran a whole bunch of executions of our name ASP.NET monsters.
Right on.
The interesting thing here is that you'll note that it was running a couple of different times. That's because in my logic here, I was actually just doing a bit of a kind of recursion where I essentially just decremented the count and then one and then put it back into the queue with the exact same kind of thing. Oh, okay. And then it will just essentially go and process it 10 different times because I gave it the count 10 in that case.
So you have an output binding there for the iCollector item, and anything that you pump into that will go back out to however you've got the integration wired up.
Exactly, and you can see in this case my output is just set to the exact same setting as my input, and that allows me to kind of do this iterative processing if I wanted to. So you can kind of build like MapReduce systems in this way in a very simple simple manner.
So you tend to do more of like the recursive approach to this that you would call a function inside of a function as opposed to putting loops in?
So it really depends. It's generally good to have a function try to do one thing at a time. So if you're going to have a loop inside of a function, it's good to just split up the work. So rather than recursively doing it, I would actually just add 10 items to the queue would actually be a better pattern. Because that means that I can then have this running on potentially 10 machines underneath the covers, processing those items.
Right, because you said you pay per execution, and that fan out happens automatically for you. So rather than looping over a collection of 100 things and doing the thing 100 times, put it into the queue 100 times of one,
Yes.
and let each of those instances of the function spin up. And
you can rely on us when you're using our dynamic plan actually scaling out for you. So you don't actually have to worry a lot about those aspects. Like I said, you don't have to worry about managing your infrastructure. You give us the work to be done and the code to do that work, and we'll manage making sure that it happens.
right on.
Okay, so you mentioned the managed type, the dynamic type that you have, but there's another type too?
Yes, you can also run on top of your classic app service plans. So today with app service, you can just add new instances. You can determine the size of the instances themselves that you run on. If you want more control over what you're running on and how much you're running on, you can always run on a normal app service plan. And it's just literally a switch that you flip when you create it. There's no other changes that happen there besides now you're responsible for managing scale yourself.
Okay, so it basically you just end up with like a pre-reserved set of machines that it runs on as opposed to fanning it out to, I assume you guys have more than 2 machines.
Yeah.
Azure, have they got their third machine yet in Azure
I
Farm?
hope so.
Okay.
I'm using one of them myself.
Right now, we don't spend a lot of time talking about the number of machines you end up running under the covers because it's kind of up to us. You don't have to care, right?
Yeah.
But really under the covers, we're running on dozens and dozens of stamps. We have some customers that are running over 100 different machines underneath the covers right now without having to call us, do anything, set anything inside of the portal.
It just happens.
They just
and
pay
again,
for the amount at the end of the month.
we're paying per execution,
Yes.
and we don't have to configure the scale out stuff.
Exactly.
Okay.
So are there
In the
some-
model under app service, are you paying per execution or are you paying for the app service in the traditional?
Under the app service plan, you're paying for the VM. So that's essentially a reserved instance, and you pay for the reserved instance. That's good, because that means that your cost will always be
know exactly how much you're gonna
predictable,
pay.
right?
Yeah.
With dynamic, it can potentially be very cheap if you have no work to be done, or if you go and throw every single tweet that was ever tweeted at it, you're going to end up paying, maybe a few $100s to keep up with it. It's still relatively
It's a
cheap.
fraction of a cent per execution. It's
Yeah, I mean, I think our preview pricing that is available right now is 0.000008 cents
Right.
for, or dollars, I guess, for every single GB sec. So that's per second of compute. And we charge you in increments of milliseconds.
Right.
So you can see that we'll charge you for as little as we possibly can, but we're charging you a slight premium on just buying dedicated capacity.
As an unrelated side note, this is better than the per 5 minute per minute stuff that Azure used to do with like compute time and stuff. So
Yes.
it's much more granular if it's down to the millisecond level.
And the point here is that you don't have to care. There's no management operation for you to call, oh, I'm done.
Right.
We only charge you for when it's being done, and you tell us when you want the work to happen based off of this event or this time,
Okay.
and then you give us the code to have it done, and you forget about it.
So developers don't have to pay for this stuff. We're probably more interested in the code, and that's what this lets us focus
Yeah.
on. And so that's really cool. And you were showing us the stuff here in the portal.
Mm-hmm.
Is there anything else? Because I mean, one of the things that I would like to see is how, like, Visual Studio is my tool set, right? That's where I want to be. That's where I want to code and stuff like
Yeah.
that. So how do I move from the portal to be working inside of Visual Studio where I've got the static type analysis and make sure that I'm not making mistakes by typing property names wrong and things like that.
Yeah, that's a great question. So you can actually just open up your function app inside of Visual Studio today. One caveat that we have today, but we're working quickly on solving it, is we are using C# scripting. And when you're in the scripting model, that means that you end up losing some of the IntelliSense because Visual Studio doesn't yet have IntelliSense for C# scripting.
Okay.
It's something that we're pushing really hard on actually supporting, but I have no committed dates on that one as well. But we are working on adding stuff into OmniSharp, and so OmniSharp and VS Code will definitely have IntelliSense. And so there'll be kind of this weird mismatch where VS Code will be more advanced than the Visual Studio tooling in some way for the C# scripting experience.
That's okay. VS Code's like uber cool anyway. So,
It's great.
Yeah.
But you can actually just do a shared library. So if you want to, you can do most of your logic inside of a shared library. You get your normal IntelliSense there, and then you can refer to your shared library from within your function. And so you can do complex things inside of a shared library that you share across many functions.
Type definitions and things like that.
Exactly.
Okay, yeah.
And then only do the lightest amount of work here in your function itself.
Very cool. Okay.
So the important piece, though, as far as I'm concerned, ends up being debugging, because the really crappy thing about just writing code inside of a portal is I'm going to have to printf debug. And this is actually the case with a lot of different serverless technology that exists out there. But Microsoft, being a kind of tooling and developer, like velocity-focused company, we really were like, hey, tooling should exist. And we're writing these things. Like we're playing with these. We're building demos and all this stuff. It was really obvious to us that tooling was important. So it's something that we've invested a lot into, even though we've removed the server. And so we've had to reinvent a couple of wheels, so to speak.
Sure.
And so what you can do is we actually have a CLI that you can run locally today on any Windows machine. And you can go ahead and do npm install -g Azure Functions -CLI. And what this will do is actually install a CLI that includes the actual host that runs on Azure. This is not an emulator.
Oh, cool.
It's the actual bits that run out there on the cloud, right? So that's great because that means that I'm not doing emulation locally. I'm doing the equivalent of what I would be doing if I was trying to run just an ASP.NET server with a local IIS instance. It's the same kind of experience.
Okay, that's really powerful because it introduces some other things that we can do locally then.
Yes, exactly.
Yeah.
Basically you then kind of own what you can do. You can even potentially grab our PDBs down and actually debug the runtime. Lots of different things become available. And we're open source, so we're not going to try to stop you from doing anything.
Right.
We might look at you like you're crazy, but we won't stop you. And so what we can now do here is I type func in there, which is the shorthand that we have. There's two other shorthands. You can go look what I like func the best because func.
Does it play some music when you do that? You need the speakers on. You didn't have it.
Yeah.
You didn't share the audio.
They accept pull requests.
They accept pull requests.
And so there's a lot of different options in here. You can go ahead and create new functions via func new. You can actually fetch your app settings down so you can work with them locally. So you're not having to set app settings locally. We'll actually manage that for you as well with func fetch. You can log in and see all of your apps. So you can see here I did a func list just previously to look up all the different functions that I have inside of my subscription that I'm looking at right now.
Does that pull it into like a user secrets kind of store or something?
Exactly. So if I actually type, this, you can actually see this .secrets file, and this is actually encrypted using my, local user permissions. So it's not something that if I accidentally upload to GitHub would be super easy to, though you should definitely not do that. And you'll see that we actually drop a git ignore file on the thing with secrets also being git ignored. So we work hard to make sure you don't do the wrong thing.
Very good. Very good.
It's still possible because we give you the control, so to speak, the rope to hang yourself with. So we go ahead and do, the thing that you're going to want to do first is just run these things locally. So go ahead and do func run, and in this case I just have that item scenario, right? And I can pass additional parameters to it, but I can also just call it. And it would be a simple 200, or just a GET request with no body, no query string if I do that. What you noticed is behind the scenes, we actually spun up a job host. And in this case, this thing ended up finding different issues with what it saw here. But it actually ends up working fine most of the time when it doesn't spit out red garbage at me. So let me just go ahead.
So this is not GA quite yet.
Yeah, no kidding. Let me go ahead and try to run my other one, which is process item. So the tooling itself is also, the service itself is not GA, but we're getting really close. The service itself is actually quite stable, but the tooling that you see here is still going to be in preview mode for just a little bit, because you'll see us doing some pretty big changes. We want to do some verb changes to make it easier to use and closer to the Azure CLI. You'll note that this is not the Azure CLI, it's the Azure Functions CLI. But I'm just going to go ahead and kill this one more time, and this is how you know this is a live-ish demo. I mean, it's recorded, but we don't like to, fake things. So what I can do here is just figure out just quickly why this might end up being broken, but it's complaining right now about my no storage account has been configured. That's interesting. So what I'm going to go ahead and do here is just quickly try to fetch my secrets again. So I did this in my Shronde microservices app. Oh, that's what I didn't do. This is a usability issue. So essentially what I need to do here is I need to type secrets. And I need to give it an actual name. So I just need to have an S there. And you see that there actually grabbed my settings.
Okay.
You're seeing more than I was planning on because I was trying to make this a quicker demo. But in this case, I can actually go ahead and do process item. Now the host starts. Now there's no red wall of garbage.
Success.
It's almost like it's required to have the configuration to talk to the service as it needs to.
Yeah, it likes to know where the storage service itself is.
Sure, so that's just the connection string to the storage account, like we would normally do for table storage or whatever the case may be.
Exactly.
Okay.
And so in this case, I get another red wall here, and essentially it's just saying I didn't pass it an object. So I'm giving it a null object, and so it yelled at me. But it's now running successfully. So if I go ahead and change this thing to actually be localhost, and we're using 7071 as our favorite setting, and we don't need this API key anymore because we're just working locally. I can actually go ahead and send it here. You'll see we get the 200 OK, and you'll see that we actually process it, and you see all of that ASP.NET Monsters logging text that we used to see inside of the portal. So a few bumps there because I didn't poke it to make sure it was fully set up. I wanted to show all the moving pieces.
But that's end-to-end.
But it works end-to-end. And the usability issues that you see there of it yelling at me when I didn't do things right, we'll end up improving those things kind of as we get the tooling to more of a GA shape.
Okay, so we're a lot closer to where we want to be for the experience of a developer then. We've got our code written in Visual Studio. We can use the shared libraries and everything. What about source control? How do if I want to do an automatic deployment, I mean, that seems to be the, that's not seems to be. It is the correct way to do things, to have some chainability with our CI/CD server or triggered off of a check-in, for example, in GitHub.
Yeah. So what you saw me here being able to do is when I did func list, you actually saw that there was also this Git URL here. This would allow me to actually just Git push directly to my app. So if I don't want to necessarily mess around with an intermediate service, I can actually just do a local Git, host it on the function app SCM site itself.
I see.
This is very similar to the way that web apps works when you do local Git with web apps.
Right.
Okay.
But if we wanted to go ahead and do GitHub, I actually kind of had started creating a repo here just to show off this initial thing. So I'm just going to create this repo here, completely empty. And we can go ahead and just push out the contents to this. So I'm going to grab this. We're going to go ahead and just add this remote piece here, if I can actually copy this properly. Thanks GitHub for that button not working.
Web development is hard.
So
It would have been fine if you'd been using Edge.
yes, good.
Everybody's favorite browser.
So here I can go ahead and do a git add all just because I'm going to be really lazy and do a git commit. And initial, because I'm going to be very descriptive and follow best practices by giving it a really descriptive name. And we can go ahead and just push. And now we actually have all of our code here in GitHub. That's great. So now we actually want to go ahead and then hook this up to a function app. So I've got this one that I've already created, and just to prove that this will actually do something, we've got this comment down here with our let's mash on that tagline. And we're going to go ahead and we want to get rid of that because that's not there in our source code anymore. You'll notice that
But
over
let's
here.
mash on that will always be there.
It'll be there in our hearts, but not in our code anymore.
Okay, that's fine.
And so now I can go ahead and click on my function app settings. We're going to go to click on configure continuous integration.
Yep.
Click on setup. If I haven't already signed in to whatever services, it'll pop up a little sign-in window. But in this case, I've already signed into my GitHub, and so it just knows who I am, my identity, and it'll just go up and look up all of my repos that are for me, public and private, so I don't need to worry about making all my repos public for this to work. And then I can just choose my project. So in this case, I can go ahead and try to find func items demo. We used master because also we're following best practices there and doing everything to master all the time. And we'll click on that, and it will take a few seconds for it to show up inside of the portal, but now we'll actually kick off continuous integration there. And if you have any custom deploy scripts, any build steps you want to do, you can even do building of your shared libraries there. If you don't want to use something like VSTS or Octopus Deploy or something along those lines, you can do it all on our services, though they're going to be limited because you're going to be using compute resources while you do that, so you have to be careful.
Okay.
But overall, it's really great for like a development environment. But for production, it would probably be a good idea not to do build for production things there because conflicting with resources and stuff like that.
Sure.
But you can see there, it'll build. There's no build steps that actually happen here because it's just kind of code. And so what this is really doing is just running our deployment script. And then boom, this will actually go ahead and overwrite our site contents.
So when I'm doing the web jobs pieces, there's actually a web jobs folder that gets created under the SCM site. I can go into the console and view that code that gets pushed up there. Is that the same case here for this as well?
Yeah, so in this case, you have access to that same Kudu site because this is powered by the same technology that powers app service. So I can click on my function app settings and click on the go to Kudu button.
Oh, perfect.
And here you can see that I can go to my site. I can go to my www root, and everything's under that. So there's no app data, web jobs, continuous folder tree to memorize in this case. Every function gets its own folder, and the folder is just named the function, and then inside of each function's folder is your run CSX or your index.js or your run FSX, etc.
Right.
So we also have F# support, but we're not getting into demoing that during this particular session today. So, but yeah, and then after that, I can go back to my site. You'll see that if I click on my items now, we've actually set them to read only because we don't want you editing things that are hooked up to a continuous integration source because if someone commits to it, you've lost your code.
Sure. Yeah.
But you'll notice here that our comments are no longer here. So now it's only in our hearts, no longer in our code.
And so it's overwritten what was there, and that's exactly what we intended to have via.
And if I go ahead and set another commit up there, well, it'll automatically trigger deploying those new changes for me. So I can easily have like a development environment where I'm running things locally, testing things locally, and I do my end-to-end tests up in the cloud on every single commit.
Wonderful.
Very cool.
Okay, I think we're out of time here, but we really
Yeah.
appreciate having you on. This is exciting stuff, and as it moves over to .NET Core, for add support for .NET Core, maybe we'll try and have you back for something over Skype, and we'll,
A celebration.
A celebration. It'll be the release party. Probably won't be Christmas. I'm just going to throw that out there. But watch on GitHub and tune back in on ASP.NET Monsters, and we'll have another party on top of the Azure Function bits.
Great. Thanks, everybody. So if you're interested, you could like, comment, or share this video. And if you have particularly interesting comments, there's a section right down there that you can fill in.
And anybody comments, questions, we got these stickers that make your laptop go faster. We'd love to send one to you, and we'll reach out to you on Twitter. Thanks, everyone.
Thanks.
Bye.